Thank you very much, Margot, for the very kind introduction. Thank you for the warm welcome. I'm very excited to be here. It's very refreshing to see so many women in a single room. I've been outnumbered for most of my life. I have 4 brothers. I'm the only girl. And I work with a lot of men because I'm in computer science. So thank you for being here. I very much appreciate it, and I'm excited to be part of this community. So thanks for the opportunity, and hopefully you will get to find my talk interesting. So before you came here, you made a lot of decisions. So what to wear, what to have for breakfast, where to sit in the room. And earlier in your life, you also had to make bigger decisions, such as what to study, where to study, whether or not to move with your partner, which city to live in. So what goes into making decisions? And are we good at making the right decisions? Are you good at making the right decisions? Is something I want to talk about today. So I live in Toronto, and believe it or not, it still snows in Toronto. So I'm excited to be here also for the weather. And one of the decisions, the big decision that I'm thinking right now is where to go next on vacation. I can't wait. And how about that? Of course, we all understand what are the benefits that goes into like going in vacation in places like the Caribbean or something like that. I can't wait, to have some relaxing time where it's warm and where there are like beaches and having a cocktail. So we understand the benefits, but what are the downsides? Setting time and money resources aside, are there any downsides going on vacation in one of those places? So I heard about accidents involving sharks, crocs. So should I be concerned for my safety? Well, let's look at the data. Actually, I should not. The likelihood that I'm being attacked by a shark or a croc is actually very, very low, let alone be fatally attacked. So I should not be concerned. In contrast, vending machines. Oh my God. Vending machines are responsible for more than 1,700 injuries on a yearly basis in the US. And vending machines alone are responsible for more than twice as many deaths as sharks and crocs combined. So why is it that we are still like afraid about sharks and crocodiles, and we can pass by vending machines like nothing happened? This is because that's the way we reason. So we are actually building on a lot of mental shortcuts or heuristics, and these shortcuts actually guide a lot of our decisions. One very powerful such shortcuts is affect. Fear and love are very powerful emotions that influence a lot, if not dictate a lot of our decisions. Assumptions is also a mental shortcut that affects decisions. I have in my head this stereotype of being in the Caribbean to be like an ideal situation for me. But perhaps this is not going to be so relaxing. Maybe the music is going to be super loud with a lot of spring breakers around. That might not be like the real picture of the reality, but my assumption is it's going to be great. And then we're also very good at drawing inferences or like making generalities based on our own personal experience of things. So the last time I went to the beach with my partner, he got badly stung by a stingray. And this is very painful. I can tell, I don't know, but it looked like so. And the one thing that is weird is that for like all of my life until now, I didn't think about stingrays. But now if you get to see me at the beach, you would find me like behaving weirdly, like getting my feet like this so that I don't risk stepping on a stingray. It's not reasonable. This probably was, an experience of a lifetime. Good experience. So the fact that I act weird on the beach is not very, serious. It's not very, doesn't have serious consequences. But our individual behavior those poor decisions may have serious consequences. So one thing that I think where individual decision put us to threat is like this incredible and reasonable pressure that some people have put on the face mask industry, referring to the coronavirus outbreak. So we know that wearing a mask, if you're not infected, going on the street is not going to help you, not catch the virus. Yet, because people have this assumption that a mask is going to protect them, and because they fear the coronavirus, their individual, own personal decision was to go and get as many masks as possible. But this is not going to help downstream because the people who really need the masks are now going to have not as easy access to them as it should. So how can we combat those, personal, shortcuts and make better decisions? Well, it's not a surprise to you. We're here for that. We need to use data. So the problem is that data can be extremely rich and extremely complex. You all know that. And this is an example of a patient, clinical record of a patient. And think about a physician before the encounter with a patient has to go through pages and pages and pages of clinical record and try to understand what was this patient's illness trajectory. So in my work, I work in visualization research, and I develop interactive visualization tools to help people make sense of real complex, rich data. And in this example, my PhD student has developed such interactive tool to help the physician, have an overview, a visual overview of the patient illness trajectory while still having easy, quick access to elements of interest in the clinical record. So it builds on machine learning, it builds on natural language processing, but the visual part and the interface is important because ultimately the physician is the one to make the decisions. And we have other examples of such interactive tools here, helping machine learning experts communicate with genetic researchers to understand what characterizes rare genetic diseases. So you're looking at pretty pictures now, but I doubt anybody in this room can make sense of those tools. And it's normal. If you're not an expert, in either genetic diseases, there's very little chances that you make sense of this. These tools have been designed for experts, and they need to be trained to actually use these tools. But data science is not always about rich, complex data. It's about complex problems, but sometimes data is simple. So how do we do when we have to communicate the data to the public? So here's an example of a topic talking about a risk assessment again. Gun violence in the US is a real concern. So this chart shows you the number of murders committed using firearms in the state of Florida. And in 2005, if you didn't know, there was a law that was enacted, the Stand Your Ground law, that basically tells that you can shoot somebody off any situation that feels threatening, and you're not gonna have any problems. So looking at the chart, after the law was passed, is that true that the very fact that you can shoot somebody when you feel threatened caused that people would not commit crimes in the first place because they were afraid of being shot? This is what the chart suggests. But is it the real story? How many of you have actually paid attention to the y-axis? It's going upside down. So basically, this chart should be turned around and put in the chronological order, and this is what everybody would have expected. Like, we had a rise in crime, in death caused by firearms after this law was passed. So it's not that the previous chart was lying to you because you had all of the information. You could actually read the axis and process this information. It's just that you have the expectation of the y-axis to go up, right? And even cognitively and perceptually speaking, this is hard to process a chart that has been turned upside down. So even when we communicate the data, as simple as a line chart can be, it can be misleading. So we worry about that when we communicate data to the public. Another example here that you are probably familiar with, don't pay attention to the data, but I'm showing the same data in two different ways. So the difference here is the scale of the y-axis. So on the left hand, you would see a close-up on the data and showing values only from 81% to 85%, whereas on the other side, you have the whole scale. So which one is better for me to communicate the information? One gives you the big picture, and you see that the difference is not as much, but the other gives you the details of the difference. So this might have an impact on the way you make decisions based on the data that you see. It's just a simple bar chart, but just like my design decision might impact your decision later on. So this is also a question that we are trying to address in my lab. Why chose we developed this just like simple animation? Can you switch back and forth? But even the one first visualization that I present to you might influence the way you read the second one. So visualizing data, working with data, making decisions with data is difficult. Sometimes we don't make necessarily the good decision because the data might not be presented in a way that you expected it to be presented, and then you misread the graph and you're being misled. And it is all about a question of perspectives. The very first time, like at the very time you decide to project the data to make it visual, you make decisions. And the fact that you decide X and Y versus Y and X might change the perception of this data. So I told you we should not rely on our mental shortcuts, and now I'm telling you let's not rely on visualization. So are we doomed? No. No. Visualization is still super powerful, but we can do better than what I just showed you. And I'm going to show you like 3 ways I believe we can try to communicate data better. So first of all, I would encourage everybody when you have to communicate data to the public to help people experience the data so that you make it more relatable to people. Let me explain what I mean. This is about environment. The fact is we have lost about 129 hectares of forest over a period of 25 years. How big is that? Who has a good grasp about these numbers? 25 years is like the time that my students in data science have been alive for. It's a long time. So do we understand really these numbers? Not quite. So how about we do this? This is equivalent to losing 20 soccer fields worth of forest every minute for 25 years. This is better. Now we have units that we can wrap our heads around. Yet we still don't have like a visceral experience of what that minute means when it comes to, taking trees down of 20 soccer fields. So let me try this. How fast can you color 20 soccer fields within 1 minute? Clearly you go past halfway through, but it's a fail. Point is, bulldozers don't fail. They get it every single minute. 20 soccer fields worth of trees down every single minute. So now, by engaging in this activity of creating this experience of what a minute is worth and what those 20 soccer fields are worth, by the act of coloring, you create an experience and you have a visceral experience of what these measures, these numbers mean. So this example comes from a very nice book that has other, it's not a relaxing coloring book at all. But it's a very interesting one. I love this project. It's fascinating to engage people through coloring in like actual data that we should all care about. And you don't have to actually, let's experience some more data. Who here drinks pop? Oh, okay. Is that a good decision? Let's look at the data. So there are 39 grams of sugar in a can of pop. But how much is that? Should you be concerned? This is, again, a value. This is a very mundane, quantity that we have to work with on a daily basis. But how good of a grasp do we have with this unit? Not much. So how about I tell you it's worth 10 sugar cubes? I doubt that I can find anybody in this room who can picture themselves put 10 sugar cubes in their mug, even if, we have like big mugs in North America. This is a lot. This is a lot. But the very fact that I re-express this abstract unit using a sugar cube that you have experience with, now my message gets across much more clearly because you have experience with that. And that's getting us back to like our personal experiences, how we can leverage those mental shortcuts by creating experiences with data that people can have a memory of because they have experienced it viscerally. So make your data relatable and engage more with your data. Befriend your data. We have a talk this afternoon that is going to cover that, the personal data of how you can learn about yourself by engaging more with your data. It is very important. So when it comes to making individual decisions, getting back to the coronavirus outbreak, I think I do have like the right habits of washing my hands and so on, but do I? So I asked myself the question, and I started to collect the data about, how many times I put myself at risk, as in somebody coughes around me, or I touch a handle, or like an elevator button, and how many times I touch my face, because that's where we get the germs from. If we touch our face after getting handles, shaking hands, and so on, that's where we get the disease from. And so I also recorded the context in which this happened, and I plotted this data by drawing, And that's my pattern throughout the day. And if we can see that in some occasion I do things right, I touch my face, but I had washed my hands, there are occasions where I did not. And so that's where I can realize, things about myself. We believe we do things, but sometimes we don't do exactly as we believe we do. And by engaging in collecting this data about yourself, you can learn not only about yourself, but also what goes into making decisions about what data to collect, when and how. What goes into making a visualization? I made design decision to make this visualization. Might not be the prettiest, but there were some design decision going into that. And by engaging with that, you can get a better understanding of the whole data science process because you apply it to yourself with small data and your own data that matters to you. So this idea is not new. It's been put forward by fantastic artists, Stephanie Pozavec and Georgia Lupi. I encourage you to check out their book, Dear Data. They've done that for several years. But I've done that manually by drawing my hand. But you don't have to. You can use tools like Data Inc. that we have developed in collaboration with Microsoft Research, where you can have a system that helps you with this process of creating those personal visualizations. Instead of drawing one drop to show each of the sentiments you've collected about throughout the week. You have like a replication mechanism. You have vector graphics that knows what color to map to what data because you specify what are the mappings. And if you're not a drawer, you can use other tool. Note that it's an all-female team. Kudos. You can actually use tools also to steal visual elements from photographs and bind these elements to data to make personal visualization that looks playful and that looks interesting visually. So engaging with data is important. Data literacy is a skill that we need to learn and that we need to teach, which brings me to my last point. It is our mission to teach data to the next generation to come. We make a lot more data-driven decisions as we go, as we're being thrown data on a daily basis. And in my lab, we develop tools to help educators teach data visualization and have children engage with data and learn what goes into, collecting data and visualizing data. But it is important as mothers, as big sisters, as aunties, that we engage, children surrounding us in doing the same and engaging with data, because that's through this means, through education, that we're going to combat all of those, irrational decisions that we can make. So to wrap up, we have a lot of data that is being thrown at us. It can be complex, but it can be mundane, like the sugar cubes. By re-expressing data to make it relatable, by engaging with data, and by teaching data, we can make a better society and hopefully make better decisions with data, ultimately. With that, I would like to thank you for your attention. I'm on time.
Thank you so much. It's amazing.